Okay, so the first concept that we are going to talk about today is coterminal angles. The idea of coterminal angles. Guys, what does the prefix co mean? Together, with, right? Mutually in common, something to that effect. So co as a prefix means together or with or something in common. And terminal is just as it sounds. If something terminates, that means it is ending, right? So remember we talked about the fact that on an angle we have an initial side where we start and a terminal side where the ray stops its rotation. So terminal means it's ending, right? Okay, so coterminal, think about then what that would mean. If we have two angles that have the same terminal side, in other words, they are stopping in the, all right, Ireland, let's spell correctly. I'm talking and trying to write at the same time. It's not working. They have the same terminal side. In other words, they end in the same spot, but we're going to have a little bit different rotation in order to get to them. So think back to that first Delta math assignment that you did, that intro to trig assignment. Some of you guys came to me and said, it said to rotate and show where this particular degree measure was. And I stopped right in the right spot, but it said it was wrong. And I looked at it and I said to you, yeah, it's because you rotated a little bit different way. You rotated negative instead of positive or positive instead of negative. Okay, but all of those angles, if we rotate and we end up getting into the same spot, all of those angle measures, they are coterminal angles. Okay, so let's look at some examples here. Think about what it's saying. We are rotating a different way, but we're stopping in the same spot. So the angle looks the same, it's just that we have a different rotation. So notice this angle alpha here. Yes, it looks like a little fish. It's saying angle alpha means we are starting in standard position and we're rotating in this positive direction to this particular location. So they're labeling that angle alpha. That's approximately what? What would that be? 180 plus 45. So this is approximately 225 degrees. Right there, that angle alpha. Okay? But then I want you to notice it's also showing starting in that same initial position and we're rotating, we're still stopping in that same exact spot. So they are coterminal angles. This rotation, though, what this is saying is we're rotating in the negative direction. That ends up being a negative 135 degrees. So what this is showing us or telling us is that 225 degrees and negative 135 degrees are coterminal angles. They start in the same spot, they end in the same spot, but we're rotating differently to get there. Okay? We need to think about what's special or what makes them coterminal. So do me a favor and plug in that negative 135 on your calculator and add 360 and tell me what you get. Negative 135, start with the negative 135, add 360, and what do we get? We get the 225, right? Okay, I want you to think we're going to add one more angle measure on here. Let's call it lambda. We're going to start here at the initial position, is the initial side, standard position. If we rotate all the way around, so 360 plus this amount more, and stop there, what would that angle be? 360 plus 225 is 585 degrees. So all of those angles, this 585, this 225, this negative 135, are all coterminal. Starting in the same position, we are rotating in a little bit different way, and then we are getting to that same stopping point, okay? If you notice angle alpha and beta over here, all they're doing is showing you this can happen in positive direction or negative direction. So there's our angle alpha. Our angle beta in this case is going all the way around 360 plus that same amount. So let's think about what angle measures would be on this, so you could kind of look at these also. That's probably about 60 degrees for this. So think about what angle beta would be. That would be 360 plus 60, so 420 degrees. So here's what I need you thinking about, or what I need you to realize. If alpha is the degree measure of an angle, then all angles measuring alpha plus or minus 360 degrees are going to be coterminal with that angle measure. And let's go ahead and put the n in there so that we can say n is any number. N is basically saying how many times are we going to rotate around? Because we can rotate once or twice. We could also rotate 20 times if we wanted to before we actually found a stopping point, right? So n could be any value. Now, we need to think about this in terms of degrees and radians. So think about the fact that if we're adding or subtracting 360 degrees, if we're in radians, that means we're going to have to add something that's equivalent to 2 pi. So plus or minus 2 pi n to represent all of the different angles that would be coterminal to this angle alpha. Okay, let's look at some examples, and then I'm going to have you guys try a few. But let's kind of talk through a few together first. All right. So it says, identify all angles that are coterminal with the given angle. So in other words, this 80 degrees, it would mean we would say 80 plus 360 degrees, plus or minus 360 degrees times n. That would be identifying all of the angles that are coterminal with that. But then it says, then find and draw one positive and one negative angle coterminal with the given angle. Okay, so first thing, I want you to think about where 80 degrees would be. What's 80 degrees going to look like? So 80 degrees would be about like this, right? So this is 80 degrees. So we want to figure out values, but we're going to actually draw and show the rotation as well for other angles. It says one positive and one negative. So what that means we're going to do is that we're going to take that 80 and we're going to add 360. So what does that give us? 440. So 440 degrees. So we want to represent an angle that's 440 degrees. So that means we're doing 360 plus that 80 degrees so that we get to there. So that would be 1. And then the second one means if we need a negative angle, then we're going to subtract 360. So if we do 80 minus 360 degrees, how much does that give us? Okay, so negative 280 degrees is also equivalent. It means the same thing. Yikes, my negative sign's not showing. So let me make that a different color just so we make sure we got. Okay, so we're starting in that same standard position. This is saying though we're rotating around this way and we're going negative 270 and then a little bit more. We're stopping in that same place. So all of those angles look the same in terms of where we're starting, where we're ending, but we've rotated 3 different ways to get that 80 degree angle, that 440 degree angle, and that negative 280 degree angle. And okay, so if we're given an angle measure and asked to find coterminal angles to that, we're just going to add or subtract 360. Okay, what that means for radian measures is that we're going to add or subtract something that is equivalent to 2 pi. So let's think about that for a second. First, we need to figure out where negative pi over 4 is. And negative pi over 4 looks about like that. Pi over 4 radians is equivalent to 45 degrees. So if you think of where negative 45 degrees is. So if you need to convert, if you're you're gonna have to start getting comfortable with those radian measures, because we're about to do a unit just strictly on unit circle where we're going to be dealing with radian measures. But for now, you probably need to convert that to think about how you're going to rotate to get to that particular place. But I want you to be doing your math using your radians. All right, so that's what negative pi over 4 looks like. We need to come up with a way of representing this positive and then negative. So that means we're going to take this negative pi over 4, and we need to add to it something that's equivalent to 2 pi. Guys, let's think about that for a second. If we have 2 pi over 1, and we need a common denominator of 4, then that means we want to use 8 pi over 4. It's equivalent to 2 pi, right? So we're going to use 8 pi over 4. If we add negative pi over 4 plus 8 pi over 4, we get 7 pi over 4. So what that's telling us then is that we start here, and a positive 7 pi over 4, if you need to convert that to help you figure out what that's equal to, then please do.
How do you know that that's where it is? 7 pi over 4?
Because I know it's a coterminal angle, so it has to look exactly the same as the original angle that I drew. Does that make sense? Do you see what I mean? Okay. All right, for the second one, we want to go more negative. So that means we're going to subtract 8 pi over 4. So we get negative 9 pi over 4. So basically, think about what that's saying. That's saying we're going to start standard position. We're going to rotate once around in the negative direction and then go to where we need to be. All right, so think about that for a second. To find coterminal angles, we are either going to add or subtract 360, or add or subtract what's equivalent to 360 in radians, which is 2 pi. Okay? All right, questions, comments on that? How'd I get what?
The 8 pi over 4.
8 pi over 4 is equivalent to 2 pi.
Why are you using 2 pi?
Because 2 pi radians is equal to 360 degrees. Okay? All right, onward.
Why didn't you do like 4 pi over 2?
We could, but we want to have common denominator. So I want that denominator. So that's a great question though, Imani. Like if we had had 3 pi over 2 as our original problem, then we would add or subtract 4 pi over 2, right? If we had, I don't know, 7 pi over 5 is our original value that we were given, then we would add or subtract 10 pi over 5. So you're always just trying to think of what would that common denominator be. Does that make sense? Okay, great question.
Did you get the...
Wait, a question.
Sorry, go ahead. Okay, next thought here. We know, we can go ahead and write this in. We know angles that are in quadrant 1 are between 0 and 90 degrees, right? This is just kind of a review of that. You guys know this. So we know quadrant 2 is between 90 and 180 degrees, between 180 degrees and 270 degrees for quadrant 3, and 270 to 360 for quadrant 4. We know that already. That's great and fine and dandy. Here's where the issue comes in. If you're given an angle measure that is not between 0 and 360, we have to figure out the coterminal angle so that we have an angle that's between 0 and 360. So as an example, if we have 435 degrees and I want to know what quadrant that's in, then the process that we're going to use is we're going to think about coterminal angles. We're going to subtract 360 from this. And what does that give us? 75 degrees. So now we know 435 degrees and 75 degrees are coterminal angles. So wherever a 75 degree angle is, that's where 435 degrees is. 75 degrees is in which quadrant? quadrant 1, so we know this would be an angle that terminates in quadrant 1. Okay, so that's one of the kind of the applications of when you're going to use coterminal angles. I'll keep going. All right, so 640, let's look at that one. Lily, can you talk me through that one?
I subtracted 360.
Okay, and what did that give you? 280 degrees. Guys, that's between 0 and 360, so we're done. That's it, just 280 degrees. Beautiful. All right, Zoe, what about letter D?
I was doing it wrong at first.
Okay, so that's a way high number, so we know we want to subtract.
360 twice.
Good, so let's subtract 360,
80 degrees.
and if you if you subtract 360 again, because that number is still bigger than 360, then we got?
It was 440.
80 degrees. Okay, so 800, 440, and 80 degrees. Those are all coterminal. All right, Carson, talk me through letter E.
I just added 360 twice.
Okay, so add 360, add 360.
That's negative 22.
Okay, that still just only gives us negative 22, so
360 again.
there we go. We got to add 360 again, and what does that give us? 338. Okay, good. I will talk you through these. 19 pi over 8. Guys, 19 over 8 as a fraction is definitely bigger than 2 pi, right? Think about what 2 pi, what would the common denominator be if we have something over 8? What would the fraction be? 16 pi over 8. So this number here is bigger than 2 pi. So we have to subtract 16 pi over 8, and that gives us 3 pi over 8. 3 over 8 is definitely less than 16 pi over 8, which is equivalent to 2 pi. So that's your answer. We don't have to subtract again or anything. Okay? All right, because Lily was asking, how do we know if we have to subtract again or add again? You need to have a number. If it's between 0 and 360 degrees, then that means it's got to be between 0 and 2 pi in radians. All right, if we have a negative angle measure, then obviously we have to add something equivalent to 2 pi. So we're going to add 6 pi over 3. So what does that give us? That gives us 4 pi over 3. So that would be the coterminal angle that's between 0 and 2 pi. Okay? Clear as mud, right? Okay, don't make coterminal angles out to be trickier than they are. Add or subtract 360 or 2 pi. That's pretty much it, right? Okay. All right, word. Yes, we have a little bit more we've got to talk about. Hang in there. Okay, guys, you all know that our sine ratio, you think of this as SOHCAHTOA, right? I'm going to write this down. But you know that the trig ratio for sine of theta is opposite over hypotenuse. The trig ratio for cosine of theta is adjacent over hypotenuse. We know that tangent is opposite over adjacent. So what you may or may not have learned yet, and this is what you're going to need to get, another thing to get memorized here, is now we are going to talk about the reciprocal trig functions. So the reciprocal trig function, the reciprocal of sine theta is cosecant theta, and it is abbreviated with this CSC. The reciprocal of cosine of theta is secant or secant of theta, however you want to pronounce that, and it is abbreviated with this SEC. We're going to write this on the next page as well, just to kind of practice with this. The reciprocal function for tangent of theta is cotangent of theta. and it's abbreviated with that COT. It is not cot, and that is definitely not sin. So it is sine of theta, and it is cotangent of theta is how we read that, okay? You've got to get memorized now that the reciprocal of sine of theta is cosecant of theta. You've got to get these relationships memorized here. So the little remember cream and sugar that I have written here is to kind of help you with that, okay? It doesn't apply to tangent and cotangent. Hopefully that one I think is pretty straightforward and easy to remember. Cotangent and tangent are going to be reciprocals of each other. What gets confusing is sine and cosecant pairing together and cosine and secant going together. But if you remember your cream and sugar, what that means is that within each pairing of reciprocals, we need a C and we need an S. So if you think about it, if we're looking at sine, we already have our S, we have our sugar, so we need our cream. So the reciprocal function has to start with a C, so that's why it's the cosecant. Okay? Whereas for cosine, we already have our cream, we have our C. The reciprocal function needs to have an S, so it's the secant or the secant. So that's what the cream and sugar is to kind of help you with that. So you're going to have to get memorized. Reciprocal for sine is cosecant. Reciprocal for cosine is secant. And vice versa. The reciprocal of cosecant is sine. The reciprocal of secant is cosine. Tangent and cotangent, like I said, those are pretty straightforward and easy. So hopefully you'll be okay with those. All right, let's jump ahead. I'm going to show you how we're going to. For me personally, I do not have memorized the fact that the cosecant is hypotenuse over opposite. What I know is cosecant's the reciprocal of sine, and I know sine is opposite over hypotenuse. So to figure out what my cosecant is, I'm going to flip it. Right? Similarly, if cosine theta, if the ratio is the adjacent over the hypotenuse, then I know that to find my secant value, I'm just going to flip that. And tangent, same thing. If it's opposite over adjacent, then for cotangent, I'm just going to flip it. So adjacent over opposite. Okay? So sorry I did not talk you through that. So like I said, I do not have memorized that cosecant is hypotenuse over opposite. I'm strictly keeping in mind what I know about sine, cosine, and tangent, and what I know about reciprocals. That's we're going to review some of this first. Yikes. And then we'll look at an example here. So the symbol for sine, we're going to write that as sine theta, and we know that that is opposite over hypotenuse. And cosine theta, we know, is adjacent over hypotenuse. And tangent of theta, no one's asking about my thetas and what that really means. Theta is the angle, the letter that we're going to use basically to represent angle measures throughout most of trig. Okay? You know how in algebra, for pretty much everything, when we were solving for x, in trig class, we're pretty much always solving for theta, that angle measure. So we use Greek letters when we're dealing with trig because basically the Greeks are the ones who basically kind of came up with or discovered trigonometry. So in honor of the Greeks, that's why we are using Greek letters like that alpha and that beta you saw earlier. Okay? All right, so let's write the abbreviations down here. The abbreviation for cosecant, which is the reciprocal of sine, so notice these are listed one above the other. These are listed one above the other, and so on. So the reciprocal for sine is cosecant, and we're going to use that abbreviation of CSC. So we have an S and we have the C together, cream and sugar. I want you to think about the ratio for this, okay? Here's the deal. And I should have written this back there and I got excited to move on. For me personally, let me go back and I'll show you here. I'm making. Okay, so let me go back. So I prefer you think about cosecant as the reciprocal of sine, or in other words, 1 over sine. For some of you, you may want to put that reminder in there, okay, that means we're flipping, and we get hypotenuse over opposite. Okay? Similarly here, the symbol that we use for secant is this SEC. And then the last one here, this cotangent. So cotangent of theta we know is 1 over the tangent of theta. So adjacent over opposite, if you wanted to think about it that way. Your choice, but I think that's more to memorize than you need to. Okay? We will practice with those, but you've got to kind of work on memorizing those as well. All right, let's look at, we're just going to do some basic trig ratios here with SOHCAHTOA, but now we're going to extend it to our reciprocals, and I'm going to kind of show you a little bit of a trick with this, okay? So if you notice, we are doing this with in reference to this angle A up here, so I'm going to put a little note up there to remind us we're looking at that. To write our ratios, the first thing we're going to have to do is Pythagorean theorem. So 7 squared plus 10 squared equals, in this case, it's b squared. The right angle is not labeled as c. If that radical can be simplified, you must simplify it. Okay, this one cannot be, for better or for worse. All right, we need to come up with, I'm going to make this bigger. You got to write kind of small in these boxes because there's not a whole lot of room and we've got quite a bit to write in there. So I'm going to make this bigger for me to write in here. The sine ratio for this particular triangle, what would the ratio be for that? Sine we know is opposite over hypotenuse, so what's the ratio?
7 over 149.
Good, 7 over the square root of 149. Now, the issue is we can't have radical in the denominator, so we have to rationalize. So if we multiply top and bottom by the square root of 149 over the square root of 149, we get 7 times the square root of 149 over 149. So that's not very pretty, but that is how you would want to write your answer for that sine value. Okay? Here's the beauty of, I want you to notice kind of the format in which I have these ratios written, and that's gonna kind of be the typical format that you will see, that you'll see the 3 trig functions that you've already learned, and then right next to them will be their reciprocals. So if we want to write the ratio for our cosecant, that's going to be the reciprocal of sine. Guys, you are not going to want to flip that and think about how to rationalize that. But we can go back and look at that particular value, and that's the one that we want to think about flipping. So if we flip that, we get that the cosecant of A is the square root of 149 over 7. Do you see that? Okay, what about cosine of A? What do we get for that one? Taylor?
It would be 10 over radical 149.
Good. 10 over square root of 149. Excellent. And then same thing, we've got to rationalize. Guys, you're gonna, if you're probably not comfortable with rationalizing yet, but you will become comfortable with not having to write out that step and just going straight to this. Okay, so this is our answer for our cosine, but I want to look at this and flip it to get my secant value. So what's my secant ratio going to be, Lily?
It's the square root of 149.
Yep, over 10. There you go. Okay, last one. This one's a little bit easier. What's the tangent ratio, Catherine? Careful, we're going from A. So if we go from A, and tangent we know is opposite,
So it was 7 over.
7 over 10. Which, by the way, I didn't do this. So what would our cotangent be? Then I'll go back and show you guys something. What would our cotangent value be? Piper, what would our cotangent ratio be? 10 over 7. We're just going to flip it. Exactly. Good. If it's helpful, like once you've figured out what side, that other side that you're missing, that type of thing, if it's helpful, then my suggestion is this is the angle that we're using. It's saying in reference to angle A. So label stuff. So put over here a little O, so you remember that's the side that's opposite. This is the side that's adjacent. This is the hypotenuse. If that's going to help you, then by all means do that. Okay? All right, quick brain break. So this has the S in it, so you know you need the C. So think about the new trig function that you just learned that has a C in front. So which one is that? Cosecant. This has the S in it, and it's the new trig function. We need the C, so which trig function is it? Cosine. Okay, cotangent is the reciprocal of tangent. That one hopefully is easier. This has the C. That's the new trig function. That has the C, so you need the S. Sine, thank you, yes, not sin. This has the C. It's cosine, so you need the S. So secant. Nice. And then tangent of theta, and then cotangent of theta. Okay. I am not going to spend time. We might, if I find that we need to review that some more, we will. You're going to practice a little bit kind of with what this next page is also. I think I'm going to talk to you. I decided I'm going to wait to talk to you about this until tomorrow or maybe next week. So let me show you what you have for homework tonight. It's this page. Yes, you're going to scan and submit. So you're just writing the ratios on this top part. So you're going to put secant of theta and then write whatever the ratio is. So you kind of need to think about what the reciprocal is first so you can figure that out. Notice down here, though, guys, you've kind of got a two-step process you have to do. You're going to want to draw a triangle. Put your theta wherever you want to, and label that triangle with the information that you are given. You're going to have to figure out that other side. Some of those are Pythagorean triples. Actually, many of them are, but not all of them. And then you have to do the same thing that you did up above and figure out, okay, now my cosecant value. Think about your reciprocal, and then you can flip it. Okay, so that's your homework for tonight. Make sure you scan and submit. Okay, I know that was long today. Like I said, I don't think in my opinion, it's not that hard. It's just that we needed to kind of talk through and process some of this. Who's got the triples for me?